In this video, we'll review how to find an angle in a different quadrant that has the same trig ratio as a given trig ratio. To do this, we're going to need to look at the definition of our trig ratios. Keep in mind that sine of theta is y over r, cosine theta is x over r, and tangent theta is going to be y over x. Let's turn our attention to sine. Now, the radius of a circle must always be positive, which means if the y value is positive, then the sine will be positive. The y's will always be positive when you're on the top of the circle. That is quadrants 1 and 2. If you're above the midline, the y is going to be positive, which will make the sine value positive. Now, if you want the sine to be negative, you need to be on the bottom of the circle. So here, if we're looking in quadrants 3 and 4, that's the bottom of the circle. Now, here's how we're going to use this. If we have an angle, for instance, in quadrant 1, that'd be the circle up top. If we have an angle in quadrant 1, then we're going to look to the left and right to find the matched angles. Quadrant 1 will have the same sine value as quadrant 2. If we're on the bottom of the circle, for instance, a red one on the bottom here, we're going to look at quadrants 3 and 4. If you know an angle in quadrant 3, look for its matched angle in quadrant 4. Looking left and right will provide the same y value, which is what sine's measured. Now for cosine, that's going to be x over r. The x is positive on the right-hand side of the circle. That's quadrants 1 and 4. So if you have an angle in quadrant 4 and you want a cosine value that's going to be the same, you'll look to quadrant 1. If you know an angle in quadrant 1, then look to quadrant 4 for the same cosine value. Here you're looking up and down. Looking up and down will still have the same x value. Now cosine is going to be negative if x is negative. That means you're going to be looking on the left-hand side of the circle. That is quadrants 2 and 3. Here, if you have something in quadrant 2, then you'll look to quadrant 3 for that same cosine value. Looking up and down is going to provide the same x value, which is cosine. Now if tangent is y over x, notice there's no r here. So in order for tangent to be positive, you need to divide, and both the y and the x have to be the same sign. So if you're in quadrant 1, x and y are both positive, which will divide to be a positive. And if you're in quadrant 3, x and y are both negatives, and that quotient will still be positive. So tangent is going to be positive in opposite places, quadrants 1 and 3. Now it's going to be negative if you divide, and one of those, either the y or the x, is negative, but only one of them. In quadrant 2, the x is going to be negative, and in quadrant 4, the y's are going to be negative. So here, it'll look like this. So the way tangent works, if you have a positive tangent in quadrant 1, you're going to find its matched angle in quadrant 3 that'll have the same positive tangent ratio. Now if tangent's negative, that means you're going to be looking in quadrants 2 and 4. Now to do any of these, sine, cosine, or tangent, you're going to need to find the reference angle. Knowing the reference angle in one quadrant will help you to find its matched angle because it'll have the same reference angle in another quadrant. So let's look at reference angles real quick. Now to avoid confusion when we're solving for angles outside of quadrant 1, we're going to use the reference angle, which we call theta prime. Theta prime helps us to find the actual angle of revolution, theta. Keep in mind, theta prime, that is the reference angle, is always a positive, acute angle that takes us to the terminal side of the nearest x-axis. Always the x-axis, not the y-axis. If you're in quadrant 2, you're short of 180. So to find the reference angle, right here, in red, theta prime, we're going to say that it'd be 180 minus theta to give you theta prime. Now, if you get in the second picture here, we're in quadrant 3, which means we're more than 180. So we'll have to do a little bit of a different correction. Here, theta prime is this piece. And if we make it all the way to quadrant 4, now we're short of 360. This will be your theta prime, the piece that takes us to the nearest x-axis, that 360 degrees. So here's how you'll do the corrections for finding theta prime. If you're in quadrant 1, you're short of 180. So it's going to go ahead and be that theta prime is 180 minus theta. In quadrant 2, you're more than 180. So the angle theta minus 180. And in quadrant 4, you're short of 360. So you're going to go 360 minus theta to give you theta prime. Now if you actually know theta prime and you want to find the angles, here's how you do it. In quadrant 1, theta is theta prime. The angle is acute and positive. In quadrant 2, if you know the reference angle theta prime, then the actual angle of revolution is 180 minus theta prime. Down here in quadrant 3, it's 180 plus theta prime because you're more than 180. And over here, you're short of 360. So 360 minus that theta prime. The theta prime tells you how much either short or further than that nearest x-axis you are. All right, so let's look at a couple examples of how we'll do this. Here I've got three problems, a sine, a cosine, and a tangent. We're going to find an angle in a different quadrant that has the same sine, cosine, or tangent value as the given value. So let's look at problem number 1 here. The sine of 190 degrees. 190 degrees is a little bit more than 180, meaning we're in quadrant 3. We're down on where sine is negative. So if we want to look in quadrant 3, we'll look to quadrant 4 for the equal sign value. I need to start by finding my theta prime. I'm a little bit more than 180, and the idea of theta prime is to tell me how much more. This theta prime, if I can find it, will have the same reference angle over here, and then to find the big angle, that theta prime is going to be how much short of 360. All right, the reference angle is going to be 190 minus 180. It's how much more than 180 we are, which means 10 degrees. 10 plus 180 is what makes it 190 degrees. Now, in quadrant 4, we're 10 degrees short of 360. So to find the actual angle of revolution, 360 minus 10 tells me 350 degrees. The sine of 190 will equal the sine of 350. Now, if you're not sure about this, you could grab your calculator and check. Put it in degrees, type sine of 190, hit enter, and type sine of 350 and hit enter. You should see that they have the same answer. All right, let's try a cosine now. Cosine of 140. Cosine of 140 is going to be a little bit short of 180, so it's somewhere up here in quadrant 2. It's more than 90, but less than 180. Now, if we're in quadrant 2, that's a place where cosine's negative. Another place where cosine negative is down in quadrant 3. So we're going to have to look up and down here. Let's start by finding our reference angle in quadrant 2, and we'll use that same reference angle to find the actual angle in quadrant 3. In one of the quadrants, we're short on 180. The other one, we're more than 180. So let's figure out how much short we are. 180 minus 140 tells me that we're 40 degrees short. To find the other angle in quadrant 3, we need to be 40 degrees more than 180. 180 plus 40 is 220 degrees. So the sine of 140 degrees, the cosine of 140 degrees will be the same as cosine 220 degrees. All right, now let's turn our attention to a tangent. 75 degrees is in quadrant 1. It's in between 0 and 90. In quadrant 1, tangent's positive. Another place where tangent's positive is going to be in quadrant 3, where both x and y's are negative. So if we're in quadrant 1, we need to find the reference angle and use it to find the angle in quadrant 3. Now, it turns out in quadrant 1, theta is theta prime. So the angle of revolution, 75 degrees, is going to become the reference angle. And then we'll use it to figure out how much more than 180 we are in quadrant 3. If theta prime is 75 degrees, to find the angle in quadrant 3 with the same tangent, we'll go 180 plus 75. That's 255 degrees. Therefore, the tangent of 75 degrees is going to be the same as tangent 255 degrees. Now I've got 3 more problems I want you to try. Pause it, work them out, and then check your answers. I'll give you a moment. All right, hopefully you've had a chance to work these. For the sine of 138 degrees, that's somewhere in quadrant 2. In quadrant 2, sine is positive, which means we'll look to quadrant 1 on the right-hand side to have that same sine value. Let's start by finding our reference angle, theta prime. We're short on 180, so 180 minus the 138 is going to give me that reference angle I need over in quadrant 1. 180 minus 138 is 42 degrees. Now in quadrant 1, theta is theta prime, so our angle is 42 degrees. Therefore, the sine of 138 degrees is the same as sine of 42. Again, for sine, look left and right. However, the next one, cosine, we need to look up and down. 305 degrees is in quadrant 4. If you're in the bottom right-hand quadrant, that's going to make cosine positive, which means we need to look at the upper right-hand quadrant, that's quadrant 1, for another equal cosine. In quadrant 4, we're short of 360. If we find where our theta prime is using that we're short of 360, that'll give me the angle that we need up in quadrant 1. Well, 360 minus 305 is going to be 55 degrees. Moving it up to quadrant 1, theta is going to be 55 degrees also. Therefore, the cosine of 305 degrees is going to be the same as cosine 55 degrees. All right, last one, tangent of 100. Tangent of 100 is going to be in quadrant 2. It's more than 90 but less than 180. Now in quadrant 2, tangent's going to be negative because x is negative. The other place where tangent would be negative would be quadrant 4. That's where y is negative. So we're going to need to go and find our reference angle. 100 degrees is going to be short of 180, so we're going to go 180 minus 100 to find that theta prime. We'll then use it to find the one in quadrant 4 by going 360 minus the reference angle. Now 180 minus 100 is 80 degrees. There's our reference angle. And that's how much short we're going to be of 360 over in quadrant 4. So 360 minus 80 tells me 280 degrees. For this last problem, the tangent of 100 degrees will will be the same as tangent 280 degrees. All right, thank you for watching. Hopefully this helped you figure out how to find those trig ratios.